Data centers are a vital part of today's society. Data center users in any environment want to position their hardware freely and add electrical and cooling capacity at will without disturbing the IT process. That is the specific task at hand of the data center designer. Low-speed ventilation data centers focuses on the IT hardware. Storage and server equipment require a standalone-like environment where they can breathe without being hindered by the neighboring servers. This approach leads to a technique whereby air is allowed to enter the room at a very low speed and freely flows to a particular location. To that end, alongside the data room, there's an air corridor with air coolers situated in the separating wall between the data room and the corridor. The air inlet to the room is controlled in a way that the IT hardware always receives sufficient air. There are no significant pressure differences in the data center. The distribution of air in the room is not regulated, controlled, or adjusted, as there's no need to. The server is saturated in air. Low-speed ventilation can be provided with a cold containment configuration, a hot containment configuration, or no containment at all. The low-speed ventilation design rules result in extremely low energy consumption in data centers, multi-positionable racks and IT hardware, on-demand expandable cooling facility, up to 20% economy on investment, up to 30% economy on maintenance costs, high availability, stable temperatures, and stable humidity, robust and simple technique in a comfortable and safe work environment. Inside a low-speed ventilation data center, low-speed air inlet by commercial air coolers. Low airspeed minimizes air resistance and eliminates hotspots due to local negative and excess pressure. There is equal static pressure everywhere. In cold containment situations, you see open floor grills connecting the pressureless raised floor and the cold corridor. The required amount of air can flow freely to any rack position. Central air demand control. 2 smart measuring tubes determine the air demand of all IT equipment present. The air circulation ventilators respond accordingly. The air flows from data room to corridor at low speed. The air returns to the corridor through large openings, causing a minimal drop in pressure. If direct outside air is used, the exhaust air leaves the data room through a roof plenum designed to expel the air unaffected by external wind pressure. Alternatively, the air can be transported out through an outside wall. To keep the air humidity within set limits, the warmed return air is humidified in the corridor if required. If direct free cooling is used, this air is let into the corridor through fresh air grills. The grills are of industrial quality and, in conjunction with air dampers, they control the incoming airflow. If outside air is used, this air is filtered up to MERV 16 quality. High-efficiency compact filters are provided on the inlet side of the low-speed ventilation air coolers. The air resistance over the large filter surface is a low 20 to 40 PA, matching the low energy consumption of the system and a long service life. In between the filters and the cooling unit are axial EC fans. The total pressure difference bridged by the fans is only tens of Pascal. The small load extends the expected useful life of the fan motors by a factor of 2 compared to the regular data center cooling equipment. When we arrive at the cooling coil, the air circle is round. The dimensions of the cooling unit, which are the result of the low-speed ventilation design rules, facilitate the use of high cooling water temperatures and makes low-speed ventilation suitable for any water cooling solution. Typical of a low-speed ventilation data center is that the building and the systems are integrated. Inside the data center, you immediately experience the cooling performance. Low-speed ventilation not only feels logical and simple, it actually is. In short, low-speed ventilation provides a flexible data center for various types of hardware and equipment. When a data center is only partially loaded with only a part of the cooling devices, the racks can be placed anywhere without compartmentalizing. When the capacity increases, air coolers can be added at any time without disturbing the IT process. Minimal energy consumption for cooling and air circulation. A PUE of 1.07 is feasible. In greenfield situations, the investment for this green solution is up to 20% lower than other modern solutions. In existing data centers, a low-speed ventilation upgrade is generally feasible. During exploitation, the benefits are numerous. In combination with the energy and maintenance costs, an OPEX saving of up to 30% is realistic. Resulting from the industrial approach, any low-speed ventilation design is a solid foundation for a data center, offering high availability. Low-speed ventilation offers IT and facility personnel many advantages in relation to a comfortable and healthy working environment. This covers aspects such as the working temperature, draft and noise levels, as well as the actual working space and ergonomics. Low-speed ventilation, where the laws of nature collaborate.